This is Ramkishore, faculty in ECE department, DBS IT, Kavali. So in today's class, we learn about PN junction diode. So in the last class, already we seen different semiconductor materials. So that semiconductor materials, so mainly consists two types. Those are nothing but intrinsic semiconductor and extrinsic semiconductor. So again, the extrinsic semiconductor will be divided into two types. Those are nothing but P-type semiconductor and N-type semiconductor. And already we seen how the P-type will be formed in semiconductor and N-type will be formed in semiconductor. And what are the majority carriers in N-type and the minority carriers in N-type, and what are the majority carriers in P-type and what are the minority carriers in N-type. Already we see those information we see in the last class. So in today's class we have to see the formation of PN junction. So first we have to see the formation of PN junction. Formation of P and N junction. So this PN junction consists, so in P-type, the majority carriers are, so this is a P-type semiconductor. So in this, the majority carriers are holes. The majority carriers are holes. So now I drawing the majority carriers, holes. And this may have the minority carriers, some place they exist the electrons. Next, we are having another type, N-type. So this N-type may have majority carriers of electrons. Majority carriers of electrons. And the minority carriers are holes. In some place that may exist, minority carriers are holes, and the remaining place that will occupy the majority carriers are electrons. So here we have the majority, we represent with number, which are one is the majority carriers. Number 1 represents majority carriers in different type of semiconductors, and 3 and the 2 represents, number 2 represents minority carriers. And here the 3 represents holes and 4 represents electrons. 3 represents holes and 4 represents electrons. So in this, the P-type semiconductor has excess number of holes. Therefore, holes are majority carriers of charge in P-type semiconductor. Similarly, N-type semiconductor has excess number of electrons. Therefore, the electrons are majority carriers in N-type semiconductor, and the combination of P-type and N-type semiconductor, it results a junction. So this combination it will be used in many applications of electronic devices. So we will see how the depletion region will be formed within the semiconductor. So the PN junction formed out of P type and N type. Whenever in this diagram, whenever we are applying some external voltage to P type and N type formation diode, so this will process the junction. That means there will be a depletion region formed within the region. So that space we can call it as a depletion region. So whenever it crosses from one end to another end, or this end to that end, so that we'll call it as a PN junction diode. So because of contact, some of the electrons from N side enter into the P side. Similarly, some of the holes from P side enter into N side. The junction, these electrons and holes combine with each other. So therefore, in the region, it is close to the junction, only the negative ions are left behind on P side and only positive ions on N side. So this results in the formation of narrow charged region on either side of the P-N junction. This N-type semiconductor is close to the junction because positively charged and P-type semiconductor close to the junction. So due to this formation, so we can call it we can form a PN junction region. So what is a PN junction diode? So the region close to PN junction is depleted of mobile charge carriers and is called depletion region. So it is called depletion region. So the symbol of PN junction diode is so the symbol. Next we have to know the symbol of PN junction diode. Symbol of PN junction diode. So it becomes like as arrow mark. So and the overflow, the current overflow indicates this P type and this is N type. So wherever the P type is anode and this is cathode material. So this is the symbol of PN junction diode. So P type and N type we are combining together, so that will call it as a PN junction diode. So a PN junction diode is one of the simplest semiconductor device which has the characteristics of passing current in only one direction. That means whenever we are applying some external voltage to this circuit, so whenever it crosses the cutting voltage for each material present in the semiconductor material present within the device, so that may crosses the cutting voltage. So then the current will flow in one direction. So it represents the opposition. So it doesn't the current flow doesn't flow in both the direction. The current will flow in one direction only. So however, the diode does not behave linearly with respect to the applied voltage, as the diode has an exponential current voltage, that is I and V relationship. So in this we get the I and V relationship, so and therefore we can't describe its operation by simply using an equation such as Ohm's law. So if a suitable positive voltage is applied between the two ends of the PN junction, so it can supply free electrons and holes with the extra energy they require to cross the junction, as the width of depletion layer around the PN junction is decrease. So that means, so whenever we have to apply a proper positive voltage and the negative voltage to this, this represents the positive and negative terminal. So whenever we increase the voltage, so that it will be enters. That means whenever we apply positive terminal to the P type and negative terminal to the N type, so it is the diode, it should be in forward bias. Forward. So whenever we can draw the relationship, the current relationship, so that is it is the voltage and it is represent the current I. The current I. So whenever if the forward bias, the positive voltage will be increases. That means if you have 1 volt, 2 volt, and 3 volt like this, so that may increasing. So whenever it crosses the cutting voltage for the cutting voltage for germanium is 0.3 volts and for silicon 0.7 volts. So whenever the diode crosses this voltage, so then it will the current will be increases. That means if the voltage increases, the current is also increasing in forward bias conduction. That means it can be acts like as a closed switch. That means whenever the switch is closes, then the current will continuously process. So whenever it will the diode will be entering into the forward bias, then it will be the switch is it acts like as a closed switch. So then the current, the entire current will turns around the circuit. So that is the operation of forward bias. So that means so it is applied between two ends of the PN junction diode. It can supply free electrons and holes with the extra energy they require to cross the junction as the width of the diffusion layer around the PN junction is decreasing. So next, when applying a negative voltage, so that means when applying a next, I would explain about reverse bias in PN junction diode. So the P-type semiconductor and N-type semiconductor in the PN junction behave as a electrodes. The PN junction consisting of P-type and N-type semiconductors provided with two terminals is called PN junction diode. So this whatever the arrowhead indicates within this diagram, a P-type semiconductor and gives the direction of flow of positive charge, which is the direction of conventional current, and this bar indicates an N-type semiconductor. In a PN junction diode, when P side is connected to the positive terminal and N side is connected to the negative terminal of battery, so the diode is said to be in forward bias condition. This forward bias condition of PN junction diode, so already we discussed in last figure. In a PN junction diode, when P side is connected to the negative terminal and N side is connected to the positive terminal of battery, diode is said to be in reverse bias condition. So in this reverse bias condition, so you have to apply the negative terminal to the anode side and the positive terminal to the cathode side. So then the conventional current does not flow through this side. It will be acts like as an open switch. So due to this, so the reverse voltage will be established within the reverse bias. That means wherever the reverse breakdown voltage exists, so that will be exist in this condition. So when the PN junction as a practical device or as a rectifying device, so we need to firstly bias the junction. That means connect a voltage potential across it. On the voltage axis above, reverse bias refers to an external voltage potential with increases the potential barrier. An external voltage which decreases the potential barrier is said to act in the forward bias direction. So there are two operating regions and three possible biasing conditions for the standard junction diode, and those are first one is zero bias, and the second one is reverse bias, and third one is forward bias. So here the zero bias is meaning of that no external voltage potential is applied to the PN junction diode. So here in zero biasing condition, so we didn't apply any external voltage for the PN junction diode. And coming to reverse bias, the voltage potential is connected negative to the P-type terminal. So here the negative and positive will be connected to the N-type material across the diode, which has the effect of increasing the PN junction diode's width. So whenever we are applying this type of external voltage, then whatever the depletion layer in the PN junction will be increases. So due to this reason, it will be acts like as a open switch. So next one, forward bias. The voltage potential is connected to positive. So here we have to connect positive to this one and the negative to N-type material. So P-type material and the negative to the N-type material across the diode, which has effect the decreasing the PN junction diode's width. So that means it will be the whatever the width will be closed in between the P-type and N-type material. Then it will act like as a closed switch. Then the conventional current will flow from one side to this side. So in forward bias condition, the current, whenever we increasing the voltage, so the current is also increasing. Within this diode. So here in reverse bias condition, so it will be that there is no current flow in the reverse bias condition. In zero bias junction diode, when diode is connected in a zero bias condition, no external potential energy is applied to the PN junction. However, if the diode terminals are shorted together, a few holes, that means the majority carriers in the P-type material with enough energy to overcome the potential barrier will move across the junction against this barrier potential. This is call it as forward current and is referred as IF. So likewise, the holes generated in the N-type material minority carriers find this situation and move across the junction in the opposite direction. This is known as reverse current and referred as IR. So this transfer of electrons, holes, back and forward across the PN junction is known as diffusion layer within the PN junction diode. The potential barrier that now exists, the diffusion of any more majority carriers across the junction, the potential barrier helps minority carriers to drift across the junction. So it is also called equilibrium or balance will be established when the majority carriers are equal and both moving in opposite direction. That means whenever we are applying the zero biasing in between P-type and N-type material, so that these two will be acts like as a shorted within majority and minority carriers of the semiconductor. So the properties of PN junction diode is, so a PN junction diode conducts electricity in forward bias condition and offers low resistance for current flow. In reverse bias condition, it offers high resistance and no current flow in this situation. So the uses of PN junction diode is, so a PN junction diode can be used as a electronic switch. So in rectifier circuit, a PN junction diode is used to convert alternating current into direct current. So this conversion is utilized in, so due to converting alternating current to direct current, so it is utilized in power supply devices found in electronic appliances such as TV, radio, tape recorders, computers and so many electronic circuits. So certain PN diodes glow on supply of electricity. So such diodes are called light emitting diodes. So these light emitting diodes will be used in digital clocks and digital electronic calculator. So these are the uses of PN junction diode. So mainly it will be used as an electronic switch and it will be used as a rectifier. So the rectifier is nothing but it converts alternating current into direct current and is also used to indicate the supply of electricity, that is nothing but LED and digital electronic calculators. When the diode is connected in a reverse bias condition, a positive voltage is applied to the N-type material and the negative voltage is applied to the P-type material. The positive voltage applied to N-type material attracts electrons towards the positive electrode and away from the junction, while the holes in the P-type are also attracted away from the junction towards the negative electrode. So the net result is that depletion layer grows wider due to lack of electrons and holes and presents a high impedance path. So almost it acts as a insulator. So that means insulator means so it doesn't allow or flow through that material. So the insulating materials are nothing but wood, glass, fiber. So these are all comes under insulating materials. So whenever the diode will be enters into reverse bias condition, so in this condition, so it doesn't allow any current through it. So the result is that a high potential barrier is created, thus preventing current from flowing through the semiconductor material. So in this state, it doesn't allow any current to this state. So this is also one type of equilibrium state. So due to this, the resulting in an increase the leakage current, but an electric current cannot flow since no circuit has been connected to the PN junction diode. So in this next we have to see, so due to this reverse bias condition, a very small leakage current does flow through the junction, which can be measured in microamperes. So this small reverse current will flow within the device, so it will be measured in microamperes. So finally, if the reverse bias voltage applied to the diode is increased to a sufficiently high enough value, it will cause the diode's PN junction to overheat and fail due to the avalanche effect around the junction. This may cause the diode to become shorted and will result in the flow of maximum circuit current, and this shown as a step downward slope in the reverse static characteristics curve below from within the negative region of the axis. So sometimes this avalanche effect has a practical applications in voltage stabilizing circuit where a series limiting resistor is used with the diode to limit this reverse breakdown current to present maximum value. So it is also used in GNOR diodes. So next case is whenever the diode will be works under forward bias condition, a negative voltage is applied to the n-type material and a positive voltage is applied to the p-type material. So if the external voltage becomes greater than the value of the potential barrier, that means for the silicon it is 0.7 volts, for the germanium 0.3 volts. So this barrier opposition will be overcome and current will start to flow. So the current will start to flow because it will be acts like as a closed switch. So this is because the negative voltage pushes or repels electrons towards the junction, giving them the energy to cross over and combined with the holes being pushed in the opposite direction towards the junction by the positive voltage. This results in the characteristics curve of zero current flowing up to this voltage point. It calls the knee on the static curves, and then a high current will flow through the diode with little increase in the external voltage as shown in below. So the current will linearly increases when the voltage will increases. So the application of the forward biasing voltage on the junction diode results in the depletion layer. So it will becoming very thin and narrow, which represents a low impedance path through the junction, thereby allowing high currents to flow. So this point at which this sudden increase in current takes place, and it will be represented in VI characteristics of the circuit. So thank you for watching this video. Please subscribe DBS Talks. Thank you.